Hi everyone, thanks all for joining my session here today. We'll be talking about the journey we had here in MetaCloud to build a multi-tenant front-end architecture for our B2B e-commerce platform. Let me by introducing myself. My name is Guilherme, I'm the CTO and co-founder here at MetaCloud, and I've been working for 17 years in the industry. If you'd like to reach out to me to ask any questions, just have a chat, or simply follow up with the content I post online, you can find here all my social links. So here at MetaCloud, we develop an e-commerce platform that is specialized for the B2B market. This platform handles all the complexities of sales between enterprises. We work with customers across different industries to help them to provide efficient digital sales channel to their customers. If you'd like to know a bit more about our company, what we do here, you can check out our website at mercloud.io. But what exactly is a B2B e-commerce? It's a platform that facilitates business transactions between multiple enterprises in the supply chain. The goal here is to establish a long-term relationship rather than one-time transactions. And differently from B2C e-commerce, on B2B we need to deal with scenarios like customized pricing models based on your customer profile targets. That can be the geolocation, customer tier, and also complex tax regimes where policies and rates are based on product and customer tax classification. And also we're talking here about bulk transactions where customers are making orders to refill their stock. So let's have a look and see how we started the first version of our application. It was a traditional React application where we wanted to take advantage of things like server-side rendering and caching on the CDN. Our MVP architecture looked like this. We had it deployed to AWS, running on a Fargate cluster behind a CloudFront CDN that was serving some static assets from an S3 bucket. This was a quite simple architecture. It helped us to get the ball rolling, onboard the first customers, but soon we start to have some constraints. We had to replicate the stack per customer, what was causing us to have high costs because each tenant have to have their own infrastructure with resource size to accommodate their own demand. And with the time passing, this is start making our onboarding process rather complicated because apart from duplicating the stack, we also had to configure. It was getting harder and harder to get it fully automated, and soon this became quite complex to manage. Not to mention that we were having some performance implications there as well. So for the next version, we had to reimagine our architecture and rebuild the application to modernize it and support increasing customer base. We had to focus mainly on scalability and reducing the management overhead we had to allow us to have a faster onboarding experience and quicker deployments. The solution then we found was to transform this into a multi-tenant architecture. But what exactly is a multi-tenant architecture? Is when you have a single instance of your application serving multiple customers, and these customers are known as tenants. This kind of architecture helps us to maximize the resource utilization in an efficient way because we're sharing the same resources with our customers. So here we can compare the two different models. So on the single tenant model, we have one environment per tenant per customer, where on a multi-tenant, we share in the same environment with each of the customers. And the benefits of multi-tenant architecture are, for example, it's cost efficient as we have resources that are shared among these tenants. We no longer need to have a separate environment and deployment for each of them. And it's scalable. You scale horizontally to accommodate the increased demand of new tenants. And usually you have one single pipeline that manages all this process. Okay, let's talk now about the technology choices then for this new version of our project. We decided to use Next.js to build it. And the main reasons we chose it were that it comes with a great developer experience. It has lots of built-in tools like routing, for example, hot code reloading. We have zero config setups where we can quickly jump into code and don't worry about the architecture of the application. And because we already had React expertise on the house, it was easier for us to stick with the ecosystem. Also, we need to mention that Next.js comes up with out-of-the-box performance optimization. For example, automatic code splitting. That's something you need otherwise to manually set up with Webpack, image optimization, and also prefetching. Not to mention, of course, the big community and great documentation they have. And we decided to deploy and run it on Vercel. First, because Vercel is the parent company behind Next, but also because Vercel helps us to do compute at the edge. Their global network will allow us to deploy to multiple locations with multi-availability zones and automatic failover. You don't need to worry about infrastructure as code. You just code. The Vercel pipeline will handle that for you. All you need to do is to connect your GitHub repo to Vercel, and then you get automatic deployment with caching validation and preview deployment, where each branch you create on your GitHub, you have a preview environment there. And also this aligns with a serverless first approach here at Mercloud. So the idea was for us to have this front end sitting behind the CDN, deployed on Vercel, running as close as possible to our users. So this would give lower latency and faster response to them. And the application will be consuming our existing APIs that are hosted on AWS. But before I start coding anything, we had to solve few challenges, and the first one was how can we identify the tenant of a given request. If we look at what happens when a user makes a request to our application, the user will go there and type a URL on the browser. The browser then will go to the internet to resolve that domain name and get back an IP address. And then that IP address will be used to know, okay, where I need to make this request to. So this will come to our application. We know that in theory this is way more complex than this, but it helps us to understand the main goal here, how it works. But when we start talking about, when we bring the scenario to a multi-tenant application, we start having different domains, different URLs pointing all to the same IP address. And all these requests are going to the same server. So the server will start questioning, okay, who's the tenant for that domain? So for this, we need to find a way where we can map a domain to a specific tenant. One common approach is to use a subdomain where you can just read that part of the URL and then you map to the tenant. But we also have the cases where our own customers, they want to onboard their own and custom domains. So how can we map a tenant that we no longer can read something from that URL that we identify that? And also we have the case where multiple domains are pointing to the same
being
tenant.
run in the browser.
And a way to solve that is to have
being
a
able to
mapping
run
table
in Figma
where
or in
we can
in
correlate
Photoshop,
which tenant
Google Earth.
belongs to each
There are
domain.
tons
So
of
every time we need
applications
to
that
ask that
benefit
question,
from
we just
using
do a lookup
WebAssembly
on that
inside
table
of their
and we find the
applications.
correlation
So
there.
definitely we see like a huge benefit when it comes
How
to
we do
running
this in
more
our
performant
application, we
applications and
use
offloading those
middlewares
tasks
in
from
Next.js.
JavaScript
So
to
middlewares,
then
they will
run
allow
directly
you
inside
to
of
run code
WebAssembly.
before a request is
And how do we
completed, and it
achieve
sits
all
in
of this?
front of your
If
application.
that
So
might be the
every
question.
request
So the
will
first one
go
is that
through
you
it.
take, like, let's say a source
And
code or a
in
module
our
or a
case,
function
we
written
use the
in any programming
middleware
language of your
to
choice. So
read
whether
the
it's
host of that
Rust,
request, reach
Golang,
out
C++,
to our
C,
API, where
and
we do
then
that
you
lookup on the
basically
table,
use
on the mapping
WebAssembly
table,
toolchain
And then
compile
once
it
that's
into
resolved,
this
we inject a
wasm
header saying, okay,
binary
this is the
format,
tenant for
and
this
that is your
request.
actual
So
WebAssembly binary
now
format,
the application,
which
every time it
then
needs to load
can
something from a
be
specific
executed
tenant,
inside of your web application
all we need to do
as
is
this
check this
JavaScript
header
glue
to
code,
get that
and this
information.
wasm module that you
And
basically
here's an example how we do
you
that in
inherit,
code.
or you
So you can
essentially
see
stream it
that
into your
we
application,
get
and
the
then you can
host name
leverage it.
there and make the
And whatever compute
request
intensive
to
tasks that
our
needs to be
API.
done, that can be
This is
handled
not actually
by
a
the
very
WebAssembly
good
module,
practice. This
because
is a
it
very
is
simple
internally having that
example
code logic that's being
because
written in that particular
the
language. For
middleware is
example,
executed in every
one of the very good use
request,
cases is that
so
if
you
you were
want to
to
avoid
try to
doing
build your
fetch
own
requests, async
in-browser
operations
video
there
editor,
because it
now
slows
there's a
down
very
your
famous open source library
your
called
request.
FFmpeg.
But you
It's
can
a
put
library written in
some
C,
caching
and
in
it's
front
mainly
of
used
it
to
on
do
top
things
of,
like being able to
this,
take
so
multiple chunks of
you're
videos
not
together,
always reaching
merge
out
them together,
to
right?
that
So a lot of like the basic
endpoint.
video editing
The next thing we had to
projects that
look
you'll build,
into
or if
was
you
the
use any video
routing.
editor, like all those
So, but
building
first
things
let's
like
understand
the
how the
timeline, or
built-in
merging
Next
together
app,
different clips, or
Next.js app
decoupling
router
clips.
works. So it
They
uses a
typically
file
use
system-based
library. It's a very
router where
famous
folders are
machine learning
used to
library,
define the
not
route,
machine learning, but
and
video editing
files are
library, right?
used
So you can
to
basically
create the
use
UI
that
that's shown
same
for that
code in C++
route segment.
that's
You can
in
also
C that's been
use
written, and then try to
specific
create a
notation to
POC that
define
allows you to then
dynamic path
run
routes.
that with Wasm,
So we
and
can
that
have
will
nested
allow,
paths
and there is actually an
for
implementation
that
for that, which is
specific
the
path
FFmpeg
parameter.
Wasm, that basically runs directly inside of the
This
browser,
router is
and
pretty
that allows you to
simple,
do more
and
complex
to
tasks like
use
creative,
it, and easily allow us to
creative,
cache the
like
rendered
let's say,
page responses. A classic example of
as an
caching looks
example,
like this. The
like let's
user
say
makes a
I'm
request
just
to a specific
thinking of
URL, the
one
server
good
renders that
example.
page and
So
returns the
let's say
user
that you're
that
building your own
response,
video
but
editor in the
also
browser,
caches the
and you
response.
have
So
a
next time the
timeline-like
user
feature,
hits
so
that segment
it
point,
requires a lot
the
of compute
cached
because
version
there's a lot
is
of
returned
seeking going on, or
immediately,
if
so we
you're
don't need to
merging together
re-render
two
that
clips,
page.
that takes a lot of compute
And
intensive
we also
resources,
use
and
the
all that can
strategy
be
of
offloaded
incremental static
to your actual
regeneration,
WebAssembly module, or even if like if you're
where
rendering the
allows
video,
us to set
right,
a
directly
TTL
from
to
the
that
browser,
cached
that
response.
aspect can be
So when
handled by
a
WebAssembly.
request is
So
made,
that's why we see that it's very useful,
when a
and that's
request
how
is
you'll
made
basically
and
pair
the
it up
content is
with a
cached,
JavaScript application. But at
the
the same
server will
time,
check
you
if
get
that
near
TTL
native
has
speeds,
expired.
because
If it has expired, we still
WebAssembly, the way that it
return
executes,
that
it's
version that
at
has
near native
cached, but in the
speeds,
background,
and it
you
also has a very
trigger
small
a new
size,
process
because
to regenerate
essentially,
that
like
page. So
as
the
compared to
next
like a container,
user
you're just
that
shipping
access that
the
same page
application code. You're
will
not
get
having
the
any
new
backend
version of it.
or
But
requirement
now
as
let's
such.
bring this to
So
a
that's why like it
multi-tenant
generates very
scenario
small binaries,
where
but
I
they are
have the user
polyglot
one
because
that
you
belongs to
have
tenant A,
the
makes that
capability of
request to that
using
page,
most of the popular programming languages and converting their functions
and
into Wasm
so
modules.
let's
So
say
that's
that
one of
this
the
page
great things about
is not in
WebAssembly.
cache,
But of
so
course, the
you
question
render
is
the
that hey,
page
like
and you
is
save the
WebAssembly only limited to
response in
browsers? Because
cache.
we saw that
And then
there's
later
so
on I
many
have a user
great
2 that belongs
applications,
to a different
but the thing is
tenant
that
and makes
you
a
can
request to that
leverage
same
the
URL.
biggest features that we
What
get
do you
with
think is going to happen there?
WebAssembly, and one of the biggest features is that
So
it
the
can
server is
run
gonna
the same Wasm module can basically
respond
run in
with
a
the
number
cached
of different
version that was
ways,
generated from
and of
user
course
1 that belongs
you
to
can leverage
another
it in
tenant.
cloud, you
So
can leverage it in serverless
usually
functions,
with
because
invalid
of the
data,
capability
that
of
data
its
doesn't
instant
belong
startup
to that
times.
tenant.
One of the great use
We
cases
need
in
to find
service
a
computing
way
is
to
the cold start
fix
time that we
this,
generally
and
see with
we need to
running
fix
your,
this. We need
like
to
let's
go
say
back and look
an
again
AWS Lambda
how
instance.
we structure our
The
routing
cold start time can be anywhere
and
from
think,
10 to
okay, how
15,
can
20
I
seconds.
reshape this
And
to
of course, like
make
the
it
benefit of
tenant
having the
aware?
capability of being able to run
So the
multi-platform,
solution
that
here
means
is
that
to
you
put
can
a
leverage
path at the
these
very
tools
root of a router,
across
where
multiple
that
different
path
platforms.
parameter is
So if
actually the
you're talking about
tenant's
Kubernetes, you're talking about
identification.
VMs,
So
it can
every
run everywhere.
page
And of course, like
below
there is
it
added benefit of getting more
has the
security.
context and
So that's
is
why, like, if we
nested
kind of
from that
understand, the
tenant
evolution
router
of the ways in
route
terms of
path.
like how,
So
like let's say we have evolved in computer
so
science. Like we
anything
started
now
with our
that
own,
we're gonna store in
on-prem
cache
servers. Then
will
we
be
went to
stored
virtual
under
machines that
that
allow us to
tenant
basically
segment. So
access
this way we avoid
high-end
mixing
machines
resources
that were
from
not
multiple
locally
tenants.
available to us via
And this
SSH
is how
service. And then we
the
moved on to
routing
containers, which
configuration
are
would
basically a
look
better
like in the
implementation of
URL. We
virtual
can
machines
clearly
in a lot
see
of ways.
that
And
now because we
essentially
have
the
a
reason
new
was
path
that
parameter
with
segment
containers,
in our router, this will be
you just
represented
package
in the
together
URL.
the
And this
application
is not
dependencies
something we
and the
really
application
want.
code itself. But that has led us
because
to
remember, we
WebAssembly,
wanted
where
to
WebAssembly
give our
is
tenants the
actually
possibility to
just
use their
carrying
own
the actual
domains for the
application code
platform. So
itself,
why do you still
and
need to
it can run
identify
anywhere that
that
you want, as
on the
long
URL?
as
For
you
sure,
are
we
there
can
on
improve
the,
this.
as long as
There
you're
was
part of the
quite a long
program. And
discussion
then of
about
course,
this topic on
with
the
WebAssembly,
Next.js
because of its
GitHub,
small size and
and it took a
capability to run
while to get a
anywhere, it
response.
is really taking
And the
up
recommendation
this kind
was
of
exactly to
architecture
use
by
this sort of
a lot of
notification on the
interest
route, like we
being
did. But they
gathered
also
in
mentioned that yes,
in
these
people.
will
So
be
that's why
shown
we are
on the
seeing that.
URL.
And of course,
And the
why
solution
should
for
one care about
that
that? So Solomon
is
Hykes created
to use
Docker. So if
URL
anyone of you have
rewrites.
used Docker
So
or
you can
desktop to run
rewrite
any
that
VMs or
URL,
clusters,
so we don't need
then
to
this
represent
is one of
that
the
anymore. But under the
slides, or
hood,
one
we
of the tweets that
still
was given by
proxying the
Solomon Hykes, who
request
mentioned
to
that
that
if
path
WASI
under the
existed with
tenant segment.
Twitter, or let's say
The way you
with
can do this
Docker,
with
then
Next.js, you
perhaps
can
does
configure
not
your Next.js
have had
config
any
file,
need
or you
to
can also do
have
that using the
WebAssembly,
your middleware.
not have Docker in the
And
first
after
place.
these
But of course,
changes, here's
WebAssembly
the
is
result.
the
So
server of
everyone
the
is
computing, and
happy.
of
We
course,
don't need to do that anymore.
if you're interested, you can definitely check out some of the
I also created
content
a
that was
GitHub
shared
repo with a
in this
reference
particular because
implementation
that gives you
for
access to the
this
bytecode alliance.
approach of
So yeah, I mean,
solving
it goes on to say
multi-tenancy
that
with
there's a lot of
Next.js.
scope
You
for
can use
WebAssembly,
it
and the
as a
founder of
template to
Docker
create
himself
your
said
next
that
application, not just if you need
how
for
much he loves
reference.
using that.
This is a public
Of course,
repo,
the basic
and you can
idea,
check out
something that we've already
using
covered,
the
is
URL
like,
or
let's
the
say
QR
you
codes
start
on the
as a
screen.
user, you
Feel
write
free
some code,
to
it's
use
written in
it
Rust,
and raise a
right?
pull request with
And then
improvements.
what
Any
you do is that
contribution
you
would be
basically use
very
the developer
appreciated then.
toolchain that is,
And
specifically
all
focused
right,
towards that particular
so
system. So in
this
this
is
case,
where we
like, you're
landed.
using Cargo
A
Build,
high
which
overview of
is
our new
the build system
architecture. The
for
front end is
Rust
hosted on
projects, and then
Vercel,
we give it the target of
on the Vercel
30,
infrastructure,
WASI
handling the
32, which
authentication
allows you to
there.
convert your Rust program into a
And
WebAssembly
the
module,
API
right?
is
And it
all
has, as you can
hosted
see, like support
on
for all
AWS.
major,
We have
sections
the
like
tenant
x64
API
architecture, x86, and ARM.
that's available
So you can do
globally,
all of that, and
but
yeah, so that's
then
like one
multiple
example that
instances
we are
of the
basically
core
going to be
API in
using. And of
different
course,
geographical
the
zones
point is
to
that
comply with
the WebAssembly
regulations, and
module
also
itself
we
cannot
have the
really do
data
anything on its
closer
own,
to where our
because it
tenant
is
users
kind of
are.
part of the security
The
sandbox,
outcomes of
which
our
allows
project
it
is
does not
that
allow any
we
external
got
function
great
calls to be
improvements in
made with it. And
performance,
in order to make
taking
those
advantage of
calls,
the
or
edge
for your
network
WASM
and
module to
CDN
interact with
caching
your
with all
files,
the
that
strategies
is
we showed.
typically done
Also, because the edge
with
network, we reduce
WASM
the
Edge, which is
latency,
like
so the
WebAssembly
servers
runtime,
are much
and
much
then we have
closer
WASI,
to
which is the
our
WebAssembly
users.
system interface. So that
We
is like
also increase the
essentially
agility of our
WASI's,
dev
the
team. We no
major
longer need to
aspect
manage a very
this session,
complicated infrastructure and
for
deployment
because
pipelines.
like WASI is the WebAssembly
It's
system
much
interface. It
easier now
allows you
to
to
build and
interface your
release
WASM
new
module
features,
through
and
networking, through
faster.
different
And
channels.
today,
And of course, as you can
it's
see, like
much easier for us to
understanding
also to
how
onboard
WebAssembly
new
works, you
tenants.
have the
The
WASM
process is
time
fully
runtime,
automated.
and then you have the WASI system
That was
interface
my talk.
APIs,
Thank
and
you
then
very
the
much
host
for
OS.
joining, and
So
reach out
that
to
is
me
like
if you
the
have
way
any
that we make
questions.
the
Thank you
syscalls.
very much. Bye bye.
And of course, like just comparing like Docker and WASM together, right? Basically, like what I'll say is that in a nutshell, both of them are great to serve with each other, especially like in terms of the weather and like everything, like just understanding that WASI or WASM and Docker both work very well together, because of the fact that both complement each other. WASM is great because of its smaller startup time. Now we know that containers can be anywhere from like a few megabytes to easily hundreds of megabytes in size, and starting them up also can take a lot of time. So if you have any high compute intensive task that can quickly spin up and you want it to shut down, then WASM can be a great tool, and you can run your other things inside of a container itself. And this kind of thing will be really beneficial. So yeah, I'll definitely recommend you to check out like both, and yeah, there should be some. Then of course, the idea really is that you can technically run Docker based or WebAssembly based workloads inside of Kubernetes as well, and that's with the help of the WebAssembly Container Edition. And that gives rise to capability of being able to run WebAssembly modules inside of Kubernetes as well. So that's like one of the great things where inside of Kubernetes, you have like, let's say, if you are not aware of the architecture, right? So you have this containerd, which is the internal brains behind, behind Kubernetes. So in one pod you can, or in one node you can run, the typical containers, and another one you can set up WebAssembly to then run WebAssembly workloads inside of Kubernetes as well. And here's like one example where you can see that, what we're just mainly doing is we have some function where we are first converting a Rust program into the, into the target. And then we will basically show an example where you first compile it into the WebAssembly module, and then we generate the file, and then we finally get it. But of course, like Spin is also another thing that allows you to basically make WebAssembly development very easier, especially if you're dealing with a lot of like Kubernetes related things. So I'll definitely recommend you to check that out. Uh, and of course, like how all of this is done. These are some of the slides that allow you to basically do it. Again, like not going too deep into it. Mainly, we're changing a lot of the configuration inside of, inside of there, and then just making them better. And of course, like all of that, like if you want to deploy WebAssembly inside of Kubernetes in an automated manner, then you can leverage KWasm project, which is very popular tool these days, and also called something called as SpinQ. And like, where are we today? So, as you saw that there's deep integration for WebAssembly with containers, with, cloud infrastructure, with machine learning. And of course, like one of the use cases that just carry forwarding and understanding the more use cases for Wasm, so that it's easier for people to bundle it and understand like what's there. And then of course, I wanted to also talk about the WebAssembly component model. So the WebAssembly component model essentially means something like this, that like let's say that you have two separate programs. One program is written in C++, the other program is written in Golang, and you create WebAssembly modules for each of them. So we have the WebAssembly C++ diagram, and then the WebAssembly, the other word diagram. But the idea really is that you are basically going to be creating like these two separate WebAssembly modules, but then both of these modules cannot actually interact with each other in a specific way, right? There has to be like that kind of scenario. So yeah, I mean, the idea really is that even with the system interface, the main focus is like, being able to make Wasm accessible outside the browser. And like, let's say now that you have written a program in C++ and Java, and you want to basically interop between them, then the Wasm modules that are there, they won't even like interact with anyone like in the session. So the idea really is that they work independently, but at the same time, we have these regular community syncs that happen, that allow you to then explain, like this primarily happens with the help of the Bytecode Alliance, where they have seminars as well. So yeah, I mean, with the component model, if there are two separate Wasm modules, they cannot interact with each other directly. That's because of the IR state, or the intermediate state, that is there. Now, in order to basically do that, what you can go ahead and do is, you can basically, create the capability of having all of the different Wasm modules that are there inside of this wrapper called as the API, and we can discuss more about that a bit more. But with the help of this bit, as you see, right, that officially, like, both Wasm modules cannot interact with each other if they have been written in separate languages. So the component model essentially is a wrapper around the core WebAssembly module. And what it allows you to really do is that all of the shared commonalities, like whether it's like the the users, the models, like all of that can be proprietary. That doesn't need to be open source, but the idea about like this component model is that it provides you a wrapper around the core WebAssembly functionality. And then we'll be using like WIT, which is essentially a type of a WebAssembly format. And you can leverage that as well. Use them, and then you can translate these with the help of the canonical API. So that means that now you can, let's say, truly have a polyglot platform where you could take an code written in Rust and import it inside of a program written in Python, because of this interop that you get with the help of this wrapper around the Wasm module. And this is how it kind of looks like. So you expose all of your imports, exports that are there in a Wasm module. And then you can, once you have defined it, you can use the component model API, or the competized API, that allows you to then define your system with multiple, multiple components, and how do you intervene between them, and how do you import them to other parts. And then, yes, we are kind of running on time, but there are a lot of like really great future things happening. We are really focusing on finding good learning curves with respect to like good important clients, and then learning about how you can implement logging sockets and debugging these modules. That's very important. And then of course we already have like the Wasm Preview 2 released, and then there'll be a lot more growth in the component model, which of course is highly going to be highly relevant even for JavaScript developers, because like you can technically like discuss that, and we'll have that discussion later. But component model will also be really great for JavaScript, because you could technically then run JavaScript functions inside of Rust, or Rust functions inside of JavaScript, with the help of this Compotize API that you have. But yeah, with that, I'll conclude my session. And if you have any questions, feel free to ask, and I'll be more than happy to answer this.